We're going to introduce the concept of converting units in this video, as well as the mechanics behind how we do that. So first, converting units, what is it? Well, it's simply being able to say that I have so much of something in one unit, cups, for example, 2.5 cups, and to re-express that in a different unit. So same amount of stuff, but if instead of describing what I have in cups, I would like to describe it in ounces, I could say that 2.5 cups is equal to 20 ounces. So these are equivalent. Now, how that's done, if you didn't know that 2.5 cups is 20 ounces, we need to take a step back to math class for a second. And the first thing we're going to review is a concept called cross-reducing. First off, it's for when you're multiplying fractions, because we're going to multiply to convert units. When multiplying fractions, you should have learned that we go straight across. Numerator times numerator, denominator times denominator. 3 times 1 is 3, 5 times 3 is 15. And you should have learned to always reduce your fractions, put them in lowest terms. Well, 3 and 15 are both divisible by 3. 3 divided by 3 is 1, and 15 divided by 3 is 5. Now, cross-reducing is simply the concept that we didn't have to reduce right here at the end. We could have gone all the way back at the beginning and seen a common factor of 3 that's diagonally placed. Since I'm multiplying fractions, I'm allowed to cross-reduce. It is the only time you are allowed to cross-reduce. Okay, so make sure that you don't try to cross-reduce when dividing fractions, adding, subtracting, or even for a proportion, which is when you have two fractions equal. So this idea that you can cross-reduce, it's only allowed when multiplying fractions. But this right here is one of the backbones of how to convert units. The next one, real quick, you know it as a math fact, maybe you don't know it by name, but it's the idea that we have a value that when we multiply it by number, we always get the number back as itself. For example, 5 times 1 is 5, so any number times 1 is that number. 1 is called the multiplicative identity, because when you multiply a number by 1, you always get that number. So these two facts together, the idea of multiplying by 1 will give us the same value we started with, and cross-reducing are the two math facts you really need. Okay, with cross-reducing, we can apply that to units. So imagine now, instead of focusing on the numbers that you have in your fractions, you focus on the units. If you're multiplying fractions with units, and you see that you have the same factor or same units diagonally placed, you can cross-reduce or cancel those out. So perhaps I was starting with miles per hours, and after multiplying by this fraction here, I'm going to end up with kilometers per hour. Okay? So back to our original example here with the 2.5 cups and 20 ounces. Let's break it down and understand how we do this. Well, first step, we're going to take our original value, 2.5 cups, and we're going to multiply by some conversion factor. Okay? And then in the end, we'll magically have ounces. That conversion factor has a couple jobs. One, its job is to be equivalent to 1, because we don't want to change the value. So if something's equal to 1, we know that we won't actually change the value of what we have here. That one's a little tricky because we're not just going to plug in a 1, but you'll see what we mean in a second. The second job is that it's supposed to cancel the units that we don't want anymore, cups, the given unit, and leave behind the new unit that we want, ounces. Okay, so to do that, what you need to do is ask yourself this question right here. What is the equivalency statement for cups and ounces? The units I have and the units I want. Well, if If you don't know that, you would look it up on a table, and you would find out that 1 cup is equal to 8 ounces. Now, these are equal, right? If somebody really loved chocolate milk, and I told them, I'll give you either 1 cup...
Deputy Gilbert, please call 6321. Deputy Gilbert, 6321.
I'll give you 1 cup of chocolate milk, or 8 ounces of chocolate milk. It shouldn't matter, because they're the same. So these are going to go into this conversion factor fraction. 1 on top, 1 on bottom, and because they're the same, we know that this is equal to 1. So we get our conversion factor to equal 1 by knowing that these are equivalent. Now, we also need to put them in so that the cups will cancel. So think back to our example here where we had the miles canceling. They're diagonally placed. So when I put in the cups and ounces, I'm trying to cancel cups, so I need cups to be diagonal from where it is at the beginning. Right now it's really on the top. If you don't see a fraction, it's itself over 1. So by putting it on the bottom of this fraction, they're now diagonal, which means the ounces have to go on top. Now we plug in our values. 1 cup equals 8 ounces. And we multiply. Multiplying fractions is straight across. Or you can cross reduce to begin if you see any common factors. Well, the cups will cancel, and then I don't see any values, numbers that will reduce, so it's straight across. 2.5 times 8, 1 times 1. 2.5 times 8 is 20. 1 times 1 is 1. I don't really need to write a denominator of 1. But also, if we pay attention to the units, the cupses are gone, and I just have ounces left. So our final answer is 20 ounces. And that is how we convert units. So in summary, you're going to have your original value times a conversion factor, and that'll give you your converted value. That conversion factor generally has the given units on the bottom, or at least diagonal from where they were, and the desired units on the other side of that fraction. And if you can make these physically equivalent, then you will get the converted value.